So if you already feel like you're struggling a little bit, let me go back to the basics to hopefully find some connections and have it help you a little bit. So let's say I did the square root of 36. I'll zoom that in. There's an imaginary 2 right there, which means we're trying to find the doubles. So in a sense, what you could do is you could tree this, and I'll show you a couple different ways to do that. There's a double, and there's a double, and then 3 times 2 is 6. You already knew rad 36 was 6, but now I'm showing it to you another way. You could have also shown it like this. 36 is 6 and 6. There's my double. That gets me the 6. I could also show it like this, and that's how it's 6, and I should be writing plus or minus. I could also write 36 as 6 squared, and then make rad 2, or square root of 2, to the 1/2. Then there's my 6. So now that you see a basic 36, let's step it up a little bit. What happens if this time I have the cube root of 32? Okay? Actually, let's start with the square root of 32. So let's say I have the square root of 32. So if I had the square root of 32 and you're doing your little doubles game, there's a double. The double goes on the outside. What's left goes on the inside. Now we know plus or minus. Or I could rewrite this as I could have kept going on the 4s, and I could have written 5 2s. And then the goal is to find the doubles. That's the circle method. So I have 2 doubles, which makes 4, and I was left with a 2. But what if this time I had the cube root of 32? And I play the same game. I go 2, 16, 4, 4, 2, 2, 2, 2. This time what I'm trying to do is not find groups of 2, I'm trying to find groups of 3. So if you look, I have one group of 3. That's what goes on the outside. But then I'm still left with this 2 and this 2. Just like this one went in the radical, this one stays in it. But 2 times 2 is 4, and then cube root of 4. It's an odd root, so done. You could also see this if I'm going to show you the circle method, and I have my 5 2s. I circle groups of 3. That gives me my 2. 2 times 2 is 4. Done. If I had the 4th root of 32, and I know that I have 2, 16, 4, 4, 2, 2, 2, 2, now I'm looking for groups of 4. So that would be my 2. And then I'm still left with that 2, 4th root, even, plus or minus. Okay? When you get really good, you'll start to find the patterns, and not that this doesn't mean that you're good, because it does. It's just a little bit quicker when you can see a pattern. So if you get really good at this and you see the game, if you go back to square root of 32, you could actually see that as 2 squared, 2 squared, 2 to the 1st. Because then those squared canceled, those squared canceled, 2 times 2 is 4, and you're left with 1, 2. Or if you see 32, and you do the cube root, it's 2 cubed, 2 squared. So that would be gone. There's your 2, and 2 squared is 4, cube root. If I did it here, I could see it as 2 to the 4th, 2 to the 1st, because that makes 2 to the 5th each time. That's gone. There's your 2, and then you have 1, 2 left. Okay? Now that we have that, let's step it up a little bit more. This time what I'm going to do is let's do the cube root of, let's see, 250, p to the 7th, q cubed, and r. Okay, let's do it, let's go even a little bit crazy. Let's do r, and then let's do t to the 4th. Okay? So if I'm going to approach this problem, if you see it, that's great. But if you don't, then that's why you do this. So I'm going to do my cute little tree. And remember, I'm trying to find piles of 3. So there's my pile of 3. 5 comes out. But I have to remember that the 2 is going to stay inside. Okay? Then I go to the p's. Since I'm doing piles of 3, I'm going to do it like this. 1, 2, 3, 4, 5, 6, 7. So I have 2 piles, p squared, and then I'm left with that p right there. Then I play the same game with the q. Piles of 3. Well, there's only a pile of 3, so that's what's done there, and there's no yellow highlighter. Then I go r. Well, there's only one R, so I don't have enough for a pile of 3, so that's what's going to be left over. And then I do the T, 1, 2, 3, 4, 1 pile, 1 left over. And then what I'm going to do now is write the cube root and see what I have left. 2PRT. 2PRT. It's an odd root, so I'm done. And honestly, that's pretty much the sum of the first section, except practicing writing things from rad form to root form. I'm sorry, to exponential form. So if I had the fourth root of 81, how could I rewrite that? I could rewrite that as 81 to the 1/4. But if I'm asking you to simplify it, what you're trying to do is think something to the 4th power so that I could cancel those. And 3 to the 4th will do that. Boom, it's gone. 3 to the 1st is 3. It's an even root, plus or minus. If you had 64 and you had the 6th root of 64, you can rewrite that as 64 to the 1/6. Now, I wouldn't want to go 8 squared because the squared and the 6 wouldn't cancel. But I wouldn't want to go 4 cubed because the 3 and the 6 would still lend itself to have a 2 on the bottom. But if I do 2 to the 6th, because I'm focusing on the 6th, then boom, it's canceled, plus or minus 2. Okay? So that's kind of the summary of day 1.